Hello 143 class, this is a homework example from your chapter 7b section. This is 7b question number 1, and this is asking, it gives you a whole bunch more information, the actual problem, talking about the George Zimmerman and Trayvon Martin trial, just to give it some relevancy. But the main question is this down at the bottom. So it's telling you you have a jury pool that has 10 men, 12 women. And what's the probability of selecting a 5-person jury consisting of all females? So what we're going to do here, first let's visualize it. We got 10 males, we got 12 females, and we got a jury pool down here that we're going to pick from these. We're going to randomly select 5 of these total people. Okay, the jury has to be all females. So that means female and female and female and female and female. And one of the things you're going to get from these types of problems is when a series of events, female and female and female, being a series of events, is connected by the word and, we multiply each of those probabilities. So we're going to do the probability of the first of the 5 is a female, and, meaning times, the probability of the second of the 5 is a female, and times the probability of the third, and the fourth, and the fifth. When we see all or none, likewise none. If it said none, that would be the probability the first is male, the probability the second is male. But just to give you a visualization, alright, the first person in the jury pool, for them to be a female, if I'm blind, like all these names are in a hat and I'm blindly drawing a name, I can pick any one of these 12 females to be a juror. Alright, the likelihood of that happening is equal to the total number of females divided by the total number that I had to choose from. That's the probability the first person that I select is a female. Well, right now the number of females is 12. The total number in here is 10 plus 12, 22 male and female together. So the probability of the first is female is 12 out of 22. Right now I'll put that 12 out of 22 down here, and we notice we've got a female in the jury pool because it's all females. So the first is a female and the second is a female. So I put a female down here, so now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 females left. So now the probability the second is a female is no longer 12 out of 22, it's now 11 out of the total number of 21. So now that's the probability the second is a female, so I'm going to pull her down here, and now that becomes the probability of the second one. Now because this is, the first is a female and the second is a female, we multiply these probabilities. So I'm going to put times dot right there. And then the pattern continues. If the third one is going to come down here, now there are 10 females and 20 total, 10 plus 10. So now the probability of the next one that we select as a female is 50-50 when we put her down there. And once again, we're multiplying because of the and. The first and the second and the third are all female. Every time we say and, we can treat that as multiplication. Alright, now the probability of the fourth juror selected is female. Now there's only 9 left. 19 total, so the probability of the next is 9 out of 19. The fourth juror gives us 9 out of 19, and finally the last juror. There's now 8 females left. There's 18 total, so the probability of the last juror selected as a female is 8 out of 18. So when we add her down here, we can stop with these calculations. We no longer need them anymore. They've served their purpose. We now have 1, 2, 3, 4, 5 fractions to indicate each of the 5 jurors, the probability of each one occurring, and the probability of all of them being female. Now, we could have stopped after the first 3 once we noticed the pattern. This is going down by 1 every time. This is going down by 1 every time because it's always the number of females divided by the total for each member of the jury. And because we're always picking a female, we're going down by 1 in the numerator, the number of females. And because the juror pool that we're selecting from is always losing a member each time we put 1 in the box here, we're also going down 1 in the denominator. This happens almost every time you ever do these all or none probabilities. If a selection process takes place and one thing happens, then another, then another, then another, many times you'll find the probability of each individual part of that sequence of events taking place, and the numerator will decrease and the denominator decrease by 1 each time. Okay, now sometimes it'll be 3 women, 2 men, 4 men, 1 woman, something like that, and then it becomes a much more difficult process. But for these all or none probabilities, this is a very common occurrence of a decreasing denominator and a decreasing numerator, all going down by that same number, 1 each time. All right, now when you put this in, you can plug it in directly into your calculator, like you see it with the each individual fraction. So 12 out of 22, 11 out of 21, all the way down to 8 out of 18. I've got all those in there. Enter the 0.03, so roughly it wanted it as a percent for this problem. So if I multiplied by 100, I'd get 3%. But another way you could do it, and if you ever have to do this by hand, or if you're asked for a fractional answer, you would reduce all of these things as much as you can, each one of these fractions. So for instance, 12 and 22 reduce to 6 and 11, and then this 11 and this 11 would cancel. 10 and 20, that reduces to a half, 1 over 2. 8 over 18 will reduce to 4 over 9, and then this 9 and this 9 will cancel. And this 2 goes into 4 2 times. And then we have, let's see, 6 times 2 on the top is 12. And then on the bottom, 21 times 19, which is 399. And then you could type that in your calculator. So 12 divided by 399, and there's the 0.03, the same number, just as a reduced fraction for the probability. But anyway, this particular problem wanted you to give a decimal or a percentage. So 0.0300 is 3%.